Okay, so I'd like to welcome you to this webinar on demystifying verbal problems with hands-on equations. This is Dr. Henry Borenson. If you encounter any technical issues, usually we don't have them, stay tuned. They should be resolved very quickly. At the end of the webinar, we'll be raffling the hands-on equations introductory verbal problems workbook along with a set of student game pieces. We know from experience that the current school approach to algebra is too abstract and an unmitigated disaster for most students. So that came out in 1998, and still today, 20 years later, the same approach that has been used for when we were in school 20, 30, 40 years ago, it's still being used. So in order to meet that need, we developed the Making Algebra Child's Play workshop. And before we can discuss the word problems, verbal problems with hands-on equations, we need to review some basics. So in hands-on equations, the students have these set of manipulatives, a flat balance, a set of pawns and cubes. And the teacher has this three-dimensional scale. Nothing moves here. It's simply used to set up the equation. And the goal in hands-on equations is to find out the value of the blue pawn. So what I want to do is jump directly to lesson 3. And I'd like to show you how essentially all third graders and certainly older students can learn to solve this type of equation in just 3 lessons. I'm not going to go through the 3 lessons, but I'll show you how they do that. So what I'm going to do is share my screen here. Okay. So this is the student scale, and this is the equation. So the idea is that the x's are represented by blue pawns. So when it says 4 x's, we're going to place 4 blue pawns on the left side of the scale. 1x, 2x, 3x, 4x. Okay, so the 4x that you see here is represented by the 4 blue pawns. Now, the plus sign is going to tell us that we need to add something to the scale. So what we're going to do is we're going to add the number 2 cubed. So you have 4x's plus 2 is equal to 3x's plus 9. So here I'm going to have 3 blue pawns and then 9 cubed. So this then is the original physical setup for this problem. Okay. By the way, we have a text chat panel, and we're going to be using it. So would you please text chat hello? You should be able to see my hello. Would you text chat hello so that I can get your responses? Do you see that? The bubble on your screen is a text chat bubble. Would you text chat hello, please? Okay. So now that we have 4x plus 2 is equal to 3x plus 9. We are ready to do our legal move. So we could take away a blue pawn from each side, maintaining the balance. We could do that a second time, and we could do that a third time. So notice that by removing the same value from both sides of the equation, the equality has been maintained. And from here, we can see that x has a value of 7, since 7 plus 2 equals 9. So I can write x is equal to 7. And then to do the check, we set up the original problem one more time. So you have 4x plus 2 is equal to 3x plus 9. And now if each x is 7 and you evaluate each side, you get 7, 14, 21, 28, 30. 7, 14, 21, and 9 is 30. So the check will be 30 is equal to 30. So this then is the basic approach that we use in hands-on equations. Would you please text chat yes if you follow what we just did? Okay, the text chat panel has the bubble. Okay, Anne, good. And Susan, would you text chat yes if you follow what we just did? Okay, good. Okay, great. Okay. I would also like to show you how we do the same problem on the interactive whiteboard. And Kimberly had expressed an interest. I think we're sending this to her, actually. So let's see how we would do this problem on the interactive whiteboard. So I already have the left side set up. On the right side, we know we need 3 x's. So you have 1x, 2x, 3x plus 9. And now we are ready to do our legal moves. We can subtract the same value from each side. This time I'll do an advanced legal move. We take 3 x's from both sides, and then you see that x is going to be 7, since 7 plus 2 is 9. And then to do the check, we reset the original problem. Okay, so this then is the basic idea. And now if you evaluate both sides, as we did before, you see that both sides have the value of 30. Okay, so this is then the basic idea of hands-on equations. And we have apps. If you have an iPad or a phone, you have hands-on equations apps that you can download and enjoy. Okay, problem solving must be the focus of school mathematics NCTM agenda for action. For many students, word problems are scary. Can I have a couple of thoughts from you? Why do you think word problems are scary for people, for students? 1 or 2 thoughts, please. I assume you agree with this statement, that for many students, word problems are scary. Why? Okay, so for one thing, students don't know where to begin. The problems look tricky. They don't know how to get a handle on the problem. Okay, so for that reason, we developed, because they don't always understand what the problem is actually asking. Very good. So in hands-on equations, we developed a Demystifying Verbal Problems workshop. This is a full-day workshop. And today, we're doing a short introduction to these ideas. So the first thing we'll consider today are problems taken from the Hands-on Equations Introductory Verbal Problems Workbook. Okay, so this is a workbook intended for grades 3 to 5, although it has many problems that would also be valuable for the middle school. So we're going to begin and take some examples from that workbook. So let's begin with this one. 5 times k's age increased by 2 gives the same result, as twice her age. Okay, I was doing some changes here. Let me see if I have the right problem. Okay, I think it's the right problem. 5 times k's age increased by 2 gives the same result as twice her age increased by 11. As you can see already, this is usually not a typical word problem from grades 3, 4, or 5, but they could really do it in those grades. You would need to show them how to do a table, and they would test it for values. But we're going to solve it algebraically. And what I'd like to do is I'd like to demonstrate the solution on this interactive application here. This is number 32. Okay, so I don't want that one. I want number 32. Okay. So 5 times k's age increased by 2 is the same as twice her age increased by 11. So how old is k? So usually the question helps us to decide how to name the unknowns. So in this case, let pawn be k's age. Okay, now, how would you represent 5 times k's age? Would it be a 5 and a pawn, or would it be 5 pawns? What do you think? Can I have your response? 5 times k's age. How would you do that? A 5 with a pawn or 5 pawns? Okay, I'm hearing 5 pawns. So let me do that. 5 times k's age. So here's 1 time k's age, 2 times k's age, 3 times k's age, 4 times and 5 times. Okay, so we now have 5 times k is age. Okay, increase by 2. Increase means we have to add, right? Increase means plus. So we're going to add a cube with the number 2. Is the same as twice her age. Twice her age would be 2 pawns. Increased by 11. Now, you don't want to put a 1 and a 1 here for 11 because this is a scale. These are weights. 1 and 1 is 2. So 11 would be a 10 and a 1. So before we go further, please review this setup. And if it's okay, text chat okay. Is this correct? 5 times k's age increased by 2 is the same as twice her age increased by 7. Okay, so it seems to be okay. So at this point then, we are ready to do our legal moves. And let's remove 2 blue pawns from each side. And in lesson 4, the students learned that we can also do legal moves with the cube. So let me take away 2 value from this side, and then the 10 and the 1 becomes a 9. So now I have 3 pawns having a value of 9, which means that each pawn has a value of 3. So solve for the pawn then would be 3. Now, we need to give the answer in sentence format. So what shall we write for the answer as a full sentence? Can I have your suggestion, please? The problem was, how old is K? So the answer would be, K is 3 years old. In other words, the pawn is just something we used as an intermediary in order to get K's age. So K is 3 years old. Now, in order to do the check, there are 2 approaches to doing the check. One is you could set up the original problem one more time, the way we had it. So let's do that. You have 5x's plus 2, 5 times our age. And here you have twice our age increased by 11. And if the pawn is 3, you now evaluate each side. So what do we have? We have 3, 6, 9, 12, 15, 17. Now, if the other side is not 17, it means that we have to review our work. So let's see. The pawn is 3. So 3 and 3 is 6, and 9 is 15, and 2 is 17. Okay, so it did work out. Okay? So that's the idea. That's the idea that we follow in doing these word problems. First, we use the pawn to represent the unknown. We use the setup. Okay, so let's go back here. So the 5-step approach that we have is we indicate what we want the pawn to represent. We set up a physical or pictorial equation. I'll show you that in a minute. We solve for the unknown. We answer the original problem in full sentence format, and then we conduct a check. Okay, now the problems that I'm showing you, give me a second here. The problems that I'm showing you are problems taken from the Hands-on Equation Verbal Problems Introductory Workbook. Now, in this workbook, we have a template to help the student. The template is very similar to what you saw on the interactive application, okay? So we're going to do the next problem using this template. And let me make this a little bigger. Okay, so it rained 2 inches on both Monday and Tuesday and 1 inch on Wednesday. It also rained on Thursday. The total amount of rain on these 4 days was 8 inches. How much did it rain on Thursday? So this is a problem 9, problem you can give to your 3rd graders. It would require them to be able to read the problem, understand it. So they can do it at their seats using their pawns and cubes. Or they can do it pictorially. Let's do it pictorially. It rained 2 inches on Monday. So we're going to make a cube. That represents 2 inches on Monday and Tuesday. On both Monday and Tuesday. Okay. And 1 inch on Wednesday. It also rained on Thursday. How would you like me to represent Thursday? Can I have a suggestion? How would you like me to represent the amount of rain that fell on Thursday? Okay, so I'm going to use a pawn, and I'm going to shade that in. The total amount of the rain on these 4 days was 8 inches. So over here, I'm going to put an 8 because we're told that the total amount of rain is 8 inches. So first of all, we left out, let pawn B, we left that out. What do we want the pawn to represent? Usually the question asked will be helpful in answering that. Let pawn be what? Thursday's rain. Okay, amount of rain that fell on Thursday. Good. Amount rain on Thursday. Okay, I'm just abbreviation here. Okay, and now we could solve, we have the setup on the right. We can solve for the pawn. We do this mentally, 2, 4, 6, 2, 4, 5, this is 8, so the pawn will be 3. And then the answer in sentence format would be, it rained 3 inches on Thursday. By the way, just for your information, the answer to every problem is not always 3. Okay, just want to make sure you're aware of that. Okay, and then to do the check, we would have 8 equals 8. Okay, fine. Okay, this is problem 47. So let me do it on the interactive application. I think it's maybe easier to see. So I'm going to go to 47 here. No, not this one. I want the other one. 47. 47. By the way, all of these problems are the same problems in that introductory workbook that I just showed you. Okay, so this problem now is a little more advanced. 3rd grade honor students, maybe 4th grade, 5th grade students. When his uncle asked Matthew to tell him his age, Matthew responded with a puzzle. Nice kid. If you take my age, double it, add 6, and then double it again, you get 48. Can you find Matthew's age? Okay, so Matthew is likes to give puzzles here. Okay, let's see if we can do this step by step. First of all, what do we want the pawn to represent? Matthew, let pawn be Matthew's age. Okay, good. Now, if you take my age, so what I'm going to do now is I'm just going to follow step by step. If you take my age, double it, okay, that's my age double, add 6. Okay, I'm going to add a 6. And then double it again. What do I need to double? Can I have your suggestion? If you take my age, double it, add 6, and double it again. Double what? Okay, Anne says all of it. Do you agree, Susan? Both of you seem to agree that it's all of it. Okay, let's do that. I'm going to double the whole thing again. You get 48, okay? I'm just going to express 48 this way. There are different ways of doing that, but I'm just going to do it this way. Now notice that we don't have legal moves with the cubes but we can perform legal moves with the pawn. We don't have legal move with the pawns, but we can perform legal moves with the cube. So if I take away 6 value from this side, this 8 becomes a 2. If I take away 6 value from this side, this 10 becomes a 4. So now I see that what? 4 pawns are 10, 20, 30, 6. So each pawn will have the value of 9, right? Answer in sentence format. Matthew is 6. 6? No, 9. 9 years old. Okay, let's do the check. This time we're going to do the check in the original problem. If you take my age, we set 9, double it, you get 18, add 6, 24, double it, you get 48. So we do see that the answer is 48, 48. How many of you like that? If you like it, say like it. Pretty neat. Okay, very good. Very good. Excelente. Okay. Okay, this one is the length of a rectangle. Okay, this will be the last problem from this introductory workbook. This is 65. Again, I'm going to do it here. I think it's easier to see. Okay, 65. 65. The length of a rectangle is 5 units more than its width. If the perimeter is 50, how long is each side? So we are told that the width, we are told here, let the width be pawn. Okay, so we've already given the student a hint. I need your help here. Using the text chat panel, I need to know how to describe the length. The length is 5 units more than its width. So can you tell me how to represent the length? Using pawns and cubes. How would you do it? Using pawns and cubes. Okay. Okay, so the length would be a pawn and a cube with the value of 5. And over here, I could put a pawn and a cube with the value of 5. Now, we're told that the perimeter is 50. So, as you know, the perimeter is the sum of all 4 sides. So, what I can do is I can set up an equation by putting a pawn and a 5, a pawn and a 5, and equal 50. Or I can simplify, and I can simply consider what we call the semi-perimeter. Can somebody tell me what I need to put on the left side of the scale? I contend that if the perimeter is 50, the semi-perimeter is 25. So what do we put on the left side of the scale? Well, the semi-perimeter consists of 1 width and 1 length. So it looks like it's going to be 1 width and 1 length. So it looks like that's the equation for this problem. So if you solve that mentally, you see that the pawn is 10. How do you see that? Because since 5 is equal to 5, these two 10s are these 2 pawns. Answer in sentence format, how long is each side? So let's see, how do we answer that question? Okay, I need your help. What's the length of each side in sentence format? The pawn is 10, so what do we have? The width is? Width is 10, and the length is 15. Okay? Okay, very good. Okay, so what do you think of this approach to working with verbal problems? Can I have your feedback, please? What do you think about this approach? Okay, I'm gonna unmute you and let's see if we can hear you. Okay, Anne, your thoughts, please. You may speak.
I think it's great because I think more kids need hands-on. They need a tactile approach to verbal problems. It helps them understand what's going on.
Tactile approach. Okay, good. Susan, your thoughts?
I agree with Anne. I think that it gives them a physical connection. They literally can touch the problem that seemed abstract.
Okay, so you saw how we were able to build up the problem step by step physically. Okay, very good. So I'm going to mute again. So let's continue with the webinar. So now I'd like to go into the Hands-on Equations Verbal Problems book. This is a book from grades 5 through high school. It has more than 350 verbal problems from levels 1, 2, and 3. It has very advanced distance problems, age problems, that would challenge your best high school students. But today's only an introduction, so we're going to tackle some of the problems here. So let's see what we have. The sum of 3 consecutive numbers is the same as twice the value of the last number. So already we're looking at a 7th, 8th, or 9th grade algebra problem. Let's assume we want the first number to be the pawn. It says we need to know how to represent the 3 consecutive numbers. Now, consecutive means like 5, 6, 7, 20, 21, 22. So if the first one is a pawn, what would be the next consecutive number? Can you text chat that, please? If the first number is a pawn, what's the number after that? It would be a pawn and a 1. And the one after that would be a pawn and a 2. Okay, pawn and a 2. Good. So now we're ready to set up the equation. The sum of 3 consecutive numbers. That means I have to add all of this together. All of this goes on one side of the equation. So I have pawn. Then I have pawn and 1. Okay, I wanted the 1 here. It doesn't matter. And then I have pawn and 2. Now, whoops, sorry about that. That's a 2. Okay, so that's the sum of 3 consecutive numbers. And all of that is the same as twice the value of the last number, where the last number is this one. So I need twice that value. So I need a pawn and a 2 and a pawn and 2. So if you think this setup is okay, please say okay. Let's double check it to make sure we have it. Okay, looks like both of you already checked it. All right, so at this point then we're ready to do our legal moves. We can take away 2 blue pawns from the left side, provided we remove 2 blue pawns from the right side. 1 pawn and 1 pawn. Now I could take away 2 value from the right side, provided I take away 2 value from the left side. At this point, it looks like we're left with a very simple equation, and it looks like the pawn has the value of 1, because 1 and 1 is 2. So let's write down pawn is equal to 1. Now, the problem said to find the numbers, so we have to answer the question, what are the numbers? The 3 consecutive numbers are. What are the 3 numbers? Well, if the pawn is 1, it would be 1 and 2 and 3. Now let's see if the check works out. The sum of 3 consecutive numbers, 1, 2, and 3, that's going to be 6. Is the same as twice the value of the last number. 2 times 3 is 6, so it does work out, okay? So that gives you an idea of how we can do a consecutive number problem with hands-on equations. And we have problems dealing with consecutive odd numbers, consecutive even numbers, but that's the idea. Okay, let's look at this one. This one, 10 years from now, Tommy will be 4 years older than twice his present age. How old is Tommy? So I need your help. I need your help. Let what? Can anybody finish the sentence? I need to represent the unknown. What would you do here? Okay, good. 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 Now, if Tommy's age now is a pawn, his age in 10 years. Notice the problem says 10 years from now. What will his age in 10 years be? If he's a pawn now, what will his age be in 10 years? He'll be a pawn in 10. Good. So now we're ready to write the sentence. So I want to close this door here. I'm getting interference. Hold on. Okay, so we now have Tommy's age now, his age in 10 years. We're ready to set up the equation. Let's see how we would do that. 10 years from now, so that's this. 10 years from now, Tommy will be, I'm going to put equality, will be 4 years older than twice his present age. I need your help. How would you represent 4 years older than twice his present age? 4 years older than twice his present age. What would you do for the right side of the setup? Well, twice his present age would be that, and 4 years older will be that. Okay, so if you look at that, that should be the setup. Check a text chat, okay, if that works. 10 years from now, Tommy will be 4 years older than twice. Okay, so if that's okay, we're now ready to use our legal move. We could take away a pawn from this side, take away a pawn from this side, and notice that we see now that the pawn is Lord 6, because 6 and 4 is 10. So we have that the pawn is equal to 6. Equals 6. And now we're ready to answer the question. Since Tommy's age now is a pawn, we can say Tommy is now 6 years old. Let's see if that works. Okay, so now we have to do the check. 10 years from now, if he's 6 now, 10 years from now he will be 16. He will be 4 years older than twice his present age. Twice 6 is 12. 12 plus 4 is 16. Okay, so it does work. Now, I hope to have a video of this. I did this a bit quickly, so there's a chance you may not have been able to follow. Or maybe you did. In a workshop, we obviously give this a little more time. But this is the way students can succeed with a regular 9th grade algebra problem years earlier. Are you both okay with this? Good. Okay. All right. Okay, I think we're going to probably stop with this problem, maybe. Now, this one is interesting. 2/3 of a number. Wow. Actually, we have a lot of problems with fractional terms in that advanced verbal problems book. 2/3 of a number increased by 4 gives the same result as 1/3 of a number increased by 8. Now, we have a problem here. We have a problem here. Do we know what the problem is? Let the number be. We have a problem. Can anybody state what the problem is? There may be an obvious problem here. Yeah, we have a whole fraction and we're working with pawns. Are we going to start cutting pawns into parts? We don't have 2/3 of a pawn. Exactly. So therefore, we need to be creative. We need to let the number be something else, not a pawn, but what? What do you think you want the number to be so that you don't have to start cutting things up? What would you like the pawn to be? What would you like the number to be? Not a pawn, but what? Going once, going twice, going 3 times. We want the number to be 3 pawns. We want the number to be 3 pawns. Why? Because if the number is 3 pawns, we now know how to represent then 2/3 of the number is, what would 2/3 of the number be? Well, it's very obvious, right? 2/3 of the number would be 2 pawns. And we also know what 1/3 of the number would be. 1/3 of the number is 1 pawn. So now we're ready to set up the problem. 2/3 of a number, 2/3 of a number increased by 4 is the same as 1/3 of a number increased by 8. There you go. I think that's the setup. Text chat okay if that's the setup. 2/3 of a number increased by 4, 1/3 increased by 8. Okay, so now we're ready to solve. I can take away a pawn from that side, provided I take a pawn from this side, and I see that the pawn is worth 4. So we have pawn is equal to 4. But the problem didn't ask us what the pawn is. There's no pawn in the original problem. The problem wants to know what's the number. So I need your help here. The number is what? What is the number? So the number is 12 because the number are 3 pawns. So the number is 12. And let's do the check to see if it works. Check. 2/3 of 12 is 8. Increased by is 8. Increased by 4, that's equal to 12. Gives the same result as 1/3 of the number increased by 8. Well, 1/3 of the number is 4 increased by 8 equals 12. So as you can see, the check does work out, okay? So in the verbal problems workbook, verbal problems book, there are a lot of problems dealing with fraction equations. We won't be doing this one. I'll read it for you, but we won't be doing it now. Santos is 3 years older than 1/3 of Wanda's age, okay? So a lot of nice things you can do. So feedback. Do you see how hands-on equations can enable your students to be successful with verbal problems? Okay, your thoughts, please. Okay, I'm going to unmute you to see if you have anything else you want to add here. Unmute. Susan, anything you care to add to what you said before?
Yes, I was totally stumped on how to represent 2/3, but it makes complete sense. And I can totally see how the students would grasp that much faster than I would because I'm stuck in my old ways. So it's really nice.
Right. It's easier to do that than to try cutting up the puns. Very good. Okay.
Exactly. Yeah.
Right. And okay, good. That was Susan. And Ann, do you have a comment?
Yeah, I totally agree with Susan, and I think it's good for our kids to learn to think outside the box, that we don't have to be limited to 2/3 and 1/3. We can change them all so they can equal a whole number more easily.
Very good. Okay, I'm going to now unmute you, and I'm going to wrap up the workshop. Okay, so available is a class set of hands-on equations. Each student has a flat balanced set of number cubes. There's a teacher demonstration scale and game pieces. Okay, this is the introductory hands-on equations, verbal problems, introductory workbooks. Has 80 verbal problems, grades 3 and up. And then this is the advanced one that has some of the latter problems we showed you today. And this is the interactive application. We have not had this available for a while, but I see that it's quite valuable. So we need to reinstate this. We need to update maybe and reinstate it. And we have workshops. We have the Making Algebra Child's Play workshop, Demystifying Verbal Problems workshop. We have Developing Fractions Sense 3 and 4, Developing Fractions Sense 5. We also have Hands-on Equations Fractions. The next webinar next week is on Hands-on Equations Fractions. Okay, we just did some work with fractions, but next week we're going to be using actual fraction blocks to solve some equations. So thank you for participating in this webinar. Please let others know about this opportunity. Now, normally we have a raffle, but today we're not going to have a raffle. We're going to, if each of you are interested in the Verbal Problems Introductory Workbook, we'll be happy to send it to you. Say yes if you would like to get a copy of it, please. Okay, very good. So thank you for joining us. If you have friends, if you have a Facebook page, it'd be nice if you posted something and helped spread the word. So thank you very much. And unless somebody has a question, we're wrapping up the webinar at this time. Okay, wonderful. Have a great day. And Ann, regards to Kim.